So let's look at what we did so far. We are we have a quiz as we just mentioned on chapter 5. Chapter 5. It is here. So for this quiz, make sure you study chapter 5 and you study the probability, the binomial, the Poisson distribution, and the normal distribution also. And one thing I need to concentrate on is let me bring chapter 5 here, the confidence interval. Yeah, we provided several methods to calculate the probability. You can use Excel, you can use uh, the formula. Uh, this is the normal distribution. You need a copy of the standard normal curve. I explained that in the recordings and also here on the PowerPoint. You should read the textbook and the PowerPoints. For example, to find the Z value for less than negative 0.86, which is 0.195, I need to use the standard normal tables. I put the standard normal tables under on the class website. So we said negative 0.186. I have, this is the table, point 1. I go to point 1. And this 8. This is 0.18. This is the 8 here. So 0.18 here. So I select the value in between these two values. Oh, it is 0.86. Again, 0.86. This is 0.8. I look at the 6. This is the 6. So this is the target value that I'm looking for, which is 0.1949, which is 0.195. Okay. You need to practice that. Uh, this is from chapter 5. One thing I need to discuss from chapter 5 is the confidence interval, which is the CI. So confidence interval for the mean. That's what we are covering in chapter 5, confidence interval for the mean. When you are asked to find the confidence interval for the mean with a specific sample size, we are using equations 517. If the sample size is large, so we are using Z. So X bar plus minus Z alpha over 2 sigma over the square root of N. So you will be given the X bar. You need to find the Z alpha over 2 based on the required confidence interval. And then you need to find sigma if sigma is not given. And N should be given. If the sample size is small, so we use T. So both tables are provided. I provided you with the T table, and here's the T table, here's the normal table, and provided you with several examples. And the confidence interval proportion for sample size N. Okay, so let's see this example. I think here's an example. The distribution center manager, uh, CyberAuto warehouse wants to find the confidence interval for the average time required for an SUS to fill an order for shipment. A sample of 16 orders is taken and the mean time was found to be 8.5 minutes with a standard deviation of 2.8 to compute the 95% and 95%. So let's compute the 95% confidence interval for the mean. So we said a sample of 16 orders, so we will be using this T. Okay, this is the first step. Decide which. So we are using the T because it is less than 30, the size. Okay. So x bar plus minus T alpha over 2 n minus 1 s over the square root of n. So what's x bar? X bar is given, it is 8.5. I put 8.5 here. Plus minus T alpha over 2. How much alpha for the 95? If we are doing 95% confidence interval, alpha is equal to 1 minus 0.95, which is equal to 0.05. This is alpha. So alpha over 2 is equal to 0.05 divided by 2. So it's 0.025. This is how we decide the alpha and alpha over 2. So I need the t for 0.025 and n minus 1. N is 16, minus 1, 15. The standard deviation is given 2.8 divided by the square root of 16. So now I need to find this value to be able to find the confidence interval. So this value, TO 25 and 15 degrees of freedom, I find it from the table, the T table. So I'm looking for TO 25 and 15. I go here. It is this one. 2.131. See, 2.131, which is T, times what is given S divided by the square root of 16. So I have 8.5 plus minus this value. So the confidence interval ended up with 7.01 or 0.007 and 9.99. Okay, this is the confidence interval I have. Okay, concentrate on this. There will be a question similar to this on the next quiz. Again, the quiz will be available on the 27th. Where is it? Quiz. Yeah, here. March 27th. So it will be available in 3 days. And then the next chapter is chapter 7. We will have another meeting, talk about chapter 7, but process control. If you took statistics or operations management, you should be familiar with the process control, how to control a process, visual inspection, complex of design, different methods used to control a process. Here we are covering the control charts, what we call control charts. control charts for variables, control charts for attributes. Okay, so we collect the data, record it, calculate the statistics, and they plot the data on the chart. And then we calculate the central line, upper control limit, what we call, and lower control limit, and determine if the data which I have is in control or no. So usually we start with control chart for the average to plot the control chart for the average, or to find out if your data is in control. First, we need to find the average of averages, which is called the X double bar. I add the averages and divide by how many averages I have. And also, I calculate the average of range. You have range, you add them up and divide by how many you have. And then we use these equations for calculating the limits for the X bar chart and the R chart. Control limits for X bar chart, X double bar, which is this I got, minus A2. A2 is a factor from the table again. I put the factor tables for you here. See, here's the factor table. So if you open this factor table, and I put many examples here in Excel, we will learn how to do that in Excel. This is the T table, this is the factor table. Again, use the factor table I provided you here on the website. Don't use anything from Google, because the numbers might be different and your answer will be wrong. So there are like different types. The numbers should be the same, but for some tables, they don't give you the exact number. And if I ask you a multiple choice question, so the answer will not be the same to my answer. So to make sure that your answers are correct, use this table. Because when I prepare the questions and create a multiple choice question, for example, I use this table. I don't use anything else. I use these tables. Okay. Sometimes you need to find the standard deviation, or we call the estimated standard deviation. So we find it by dividing the average range divided by D2. Also, D2 is a number from the factor table here based on the sample size. So if I know the sample size here, so for example, the sample size is 10, I can find D2 here. It's 3.078. Okay, 3.078. This is the R bar. Oh, this is an example here. We are given a real example where this company, they received data. They are making windows or something, and they have data. They want to know if this data is in control or no. They are making windows, and it says here they received some complaints about narrow misfitting gaps between the upper and lower window, and the plant manager wants to evaluate the capability of the critical cutting. It's the problem with the cutting. So this is a real example. The normal specification for the cutting operation, oh, this is the nominal, which is 25.5 with a tolerance of 0.03. Inspect 5 consecutive window panel in the middle of each shift over 15 days. So they collected this data. This is the data that they collected, and they want to know if their process is in control or no. You see the data. So we have a sample of 5. So the sample size is 5 here. We don't care about the names. And how many here? It depends from 4 to 33. It looks like the samples, we have 30 samples. Again, this is very important here. This point is very important. So we have 30 samples. We have 30 samples. And the size of the sample is 5. Okay, this is the data. And the goal, we want to calculate the control limits and center line using X bar and R chart for this problem. So the first step, what they did, they calculated the average for each sample. So the first sample, this is the average. This is the average for the second one. Let me see if I have Excel sheet for this example. Yeah, I'm solving another example, but so 25.05 plus this divide by 5. They got the average and they got the range with the maximum of this, which is I think 25.505 minus the 25.4093. This will give them the range, and we do the same thing for each one. And then we calculate the upper control limit or lower control limit. So what's given here? N equal to 5. So I go to the table and 5, this is N equal to 5. I have two values, A2, okay? Yeah, I need this value, A2, which is 0.577. And I need also later D2, which is 2.326. Later, I need D3, which is 0, and D4, which is 2.114. I put this here, and then I say the lower control limit for R chart is D3 times R bar. We said D3 is 0, right? So let me add D3. We found it from the table. D3 is equal to 0. So D3 is equal to 0. So lower control limit for R0. D4, which is 2.114 times the average of ranges, which I found from here. You see these ranges? I find the average for these. And the upper control limit X bar is equal to X double bar minus A2 R bar. Again, X double bar, I find this is the average. I find the average for these X double bars. I think I have the data for this. Let me see. For this. For the other example. Anyway, we go over the heartbreak example and see how we find the average. But this is this example just to demonstrate how to collect, extract the information from the table and find x double bar, which is calculated, minus A2 from the table times R bar. So in this way, I find the upper control limit x bar and the lower control limit x bar. And then we plot all these. So this is the R chart. This line is the ranges. This is the upper control limit range. This is the range average, the central line. We call it the central line. This is the lower control limit. The same thing here. These are the average. Each dot is one of the averages. These are X bars. This central line is the X double bar. I will go over another example, and we will, this is the lower control limit. This is the upper control limit. Okay. So for this case, the sample, you decide which sample is out of control. For example, sample 24 out of control from R chart, sample 9 and 24 out of control. It's just common characteristics chain was process operator. So you decide who is responsible for this out of control. Okay. So uh, please read chapter 7, all the information on chapter 7. Okay, here's chapter 7 information. As I mentioned, we have a quiz. It will be available in 2 days or 3 days on the 27th. Make sure you take this quiz. It covers chapter 5. Oh, it will be available tomorrow. Okay. 20 points. It's easy. Just take it. And then read all these. So we will review again chapter 7 next week, and then you can start taking the assignment. But review first chapter 7, and again we will cover more examples next week. I will go over a complete example where I build the control chart, find the limits, and calculate what we call the capability. We have something called capability, which is the, I just saw the slide for the capability here. Yeah, here, CP. We will learn how to calculate the CP, the process capability, which is upper specification limit minus lower specification limit divided by 6 times sigma. When we are building the X bar and R chart, we can calculate sigma hat, which is equal to R divided by D2, where D2 from the table, R bar from the data. The upper specification limit. So you will be given the tolerance. Let's say the tolerance is 25 plus minus 1. So the upper specification limit is 26, which is 25 plus 1. The lower specification limit is 24, for example. It depends on the tolerance and the average or the average which is given. So you subtract this and then you already calculated this. We will go over a detailed example, but I want you first to study chapter 7, and then after that we will cover more examples, and then we should be able to do the homework and take the quiz, which is for this chapter. Any questions? Okay. If no questions. Yeah, some student asked me about their grades change yesterday. I didn't change any grade. I don't change. But when I added the chapter 5 quiz, uh, the the Canvas like assigned 0 for everybody, and this changed the grade. But that doesn't mean anything. I change it back. So, or when you take the quiz, it will consider your grade and it will not consider the 0 unless you miss the quiz. It will be 0. If you have no questions, I will end this. Make sure you attend next week. We have another meeting next week. These meetings are very important. It will help you to succeed in this class, you know. Okay. Any questions? Okay. Thank you. I will post this recording on the class website. Thank you.